Now we go on to two-step problems. And in order to do that, we actually need to change our thinking when it comes to the order of operations. Because here we kind of have to do the inverse operation to get rid of the things that are attached to the variable. So we kind of have to do the opposite of order of operations, meaning we're going to actually go in the opposite direction. So let's remind ourselves what the order of operations is. When we're simplifying expressions, we do the normal order of operations. When we're isolating variables in equations, we go the opposite way. Some students, as soon as they see this, they'll go, SADMEP. And I'm like, sure, yeah, SADMEP. Anything to help you out. I guess this is kind of a poor example because it's just a single step. Here, let's do a double step problem because that will help us out. So since we're isolating the variable, we want to break apart the weaker bonds first. This 31's on the other side of the equal sign, so that doesn't really matter when it comes to this. So I'm only looking at the 4 and the 3 here. Well, the 4 is attached to the x by multiplication. The 3 is attached to the x by addition. So that's the one I want to get rid of first. The reason why we're going backwards through the order of operations is if I knew the value of this variable, then I would multiply it by the 4 first. Then I would add the 3. But since I don't know what this value is, I need to instead break apart the bonds, kind of unraveling the onion, unraveling the ogre. Let's just do that. So the 3 is the weaker bond, so I'm going to subtract 3 from both sides. So we're left with 4x equals 28. Now we'll divide both sides by 4, which gives us x equals 7. A great way to check if you did this properly is to put what you found the variable equal to, plug it back into the original equation. Whenever your teacher asks, check your answer, this is how you do it. You found your answer, you found your value for x. You're checking it by saying, okay, you're claiming that x is 7. Let's see if that's true. Do regular order of operations, and then if you have a true statement at the end, like if nothing absurd happens, then you know you did it right. For, again, any substitutions, we're going to use parentheses. Plus 3 equals 31. Everything else is the same. Let's say we can ignore the 31. Like I'm not gonna look at it for a minute. If this was the problem, is to simplify this expression, you're going to multiply the 4 by the 7 first, then add the 3. That's why we have to break apart the weaker bonds first to find out what that variable is, so then when we plug it in, we can do normal order of operations to expand out. I hope that makes sense, because it at least makes sense to me. 28 plus 3 equals 31. 31 equals 31, which is correct, which means we did it right. And yeah, that's how you do two-step problems. The algebra here, yeah, this is real algebra now. The two-step problems are really the first step into how complicated these algebra problems can get. I can do another example if you guys want. I guess you don't have a choice because I'm just going to do it anyway. X divided by 5 minus 4 equals 16. So what's the weakest bond attached to the x? This 5 is attached to it by division, this 4 is attached to it by subtraction, and 16's on the other side where it belongs. So here, it's this subtraction. So we want to do the inverse operation of subtraction, which is addition. So we're going to add 4 to both sides. So we get x divided by 5 equals 20. as soon as I see, like, some sort of multiplication problem with 5 and 20, my mind immediately goes to 4, right? Because 5 times 4 is equal to 20. But don't let familiar numbers like factor pairs with, smaller numbers like this, don't let that heuristic override what's actually happening here in the problem. Answer is clearly not 4 because that would be 20 divided by 5. Multiply by 5 because it's divided by 5 here. These cancel. And we're left with x equals 20 times 5, which is 100. Let's check it. 100 divided by 5 minus 4 equals... How about a 4? I guess that's better. 16. 100... And nothing's giving back those parentheses. 100 divided by 5 is 20. Minus 4 equals 16. Yeah, 16 equals 16. Cool. You did it. These are two-step problems in a nutshell. I would highly recommend drilling a bunch of these out on your own. I'm sure your teacher is giving you several homework assignments of these things, or, will if you're jumping ahead. It's just really important to have this concept of the two-step algebra problems. The idea of not only going backwards through the order of operations to isolate the variable, but to apply the inverse operations properly. Bellatrix agrees.